My name is Roger Assaker. I'm the CEO of 10xICME Engineering and Chief Material Strategist for MSC Software. To help our customers in the material area across segments and across materials, we have created an extensive, robust, and easy-to-use ICME solution to bridge the gap between manufacturing and end-part performance via the materials. ICME is integrated computational material engineering. This extensive solution is built on 10 building blocks, and I will be talking about each one of them. The first building block is virtual material development. We have an extensive tool based on the Digimat product, which allow you to predict the mechanical, thermal, electrical behavior of a material based on the materials constituting this and the underlying microstructure. This underlying microstructure, it can be built completely into our product, or it can be coming from CT scanning, where we have partners in this area, or it can come from molecular dynamics, where we also have partners. The second building block of our material strategy, virtual material testing. Now that you have developed your material, the second part is that you need to characterize it. You need to test this material extensively to understand how it behaves to be able to design your product. We have developed a virtual testing software with a combination of virtual and physical testing with a hybrid test matrix. We can reduce the time of testing by 2, so 4 years instead of 8, and we can reduce the cost by almost a factor of 3, so 1 million instead of 3 million. Number 3 is data management. We have our Material Center tool, which allow you to manage your data and to organize the access to this data on an as-needed basis. With this solution, you can save a lot of money in redundant testing. You can protect the intellectual properties of your organization. Number 4 is the Material Exchange Platform. Digimat MX is the Material Exchange Platform, which connects material suppliers to the end users. In this platform, material suppliers can develop very accurate material models for their customers to use, and they can provide this material models through our exchange platform, where they can encrypt and protect the models and protecting their IP while helping their customers. The fifth component is material compliance and sustainability. Today, it's very important to make sure that your product is at 1, compliant with regulation, and 2, sustainable. We own material data. We have tools and solutions to create materials, to characterize them, to virtually test them. It's natural for us to study the compliance and sustainability of the materials. This is done with a strong partnership with compliance companies and with companies like iPoint out of Germany. Number 6 is the effect of manufacturing. Our technology will allow you to bridge the gap between manufacturing and end product performance via the material. This is done across material systems. We start with reinforced plastics, for instance, where injection molding of reinforced plastic will orient the fibers inside the part. This will allow 10 to 15% additional mass reduction, which can be huge if we translate it into the number of products that are produced. Number 7 is accurate material modeling. So we have an extensive knowledge about material to find the right material model and feeding it with the right data to make sure that your end simulation is accurate. Any simulation, being a car, an aircraft, an electronic part, it's all based on accurate material model and accurate material data, and this is what we provide. The 8th building block of our 10x ICME strategy is manufacturing. We rely on information from manufacturing process to model behavior of the material in the final part. This information can come from testing, or it can come from simulation. And one of the hottest topics today is additive manufacturing. So we developed an end-to-end solution for additive manufacturing built on 3 components: designing material for additive manufacturing, simulating the process of additive manufacturing, and finally model the performance of the printed part as a function of the manufacturing process and of the material. The 9th block of our ICME strategy is material intelligence. Material intelligence is about using artificial intelligence for materials. The idea of combining physical testing and virtual testing to create an important data set, and with this data set, we apply artificial intelligence to save and to improve accuracy. Number 10 is a digital thread and material-centric digital twin. So what we are developing is connecting our software together and the data flow all together to model the entire manufacturing line, from getting the material in to getting the final product out. And the first project that we are starting on this is in collaboration with Purdue University in the US. For the last 15 years, we worked a lot on reinforced polymer. Today, we are investing more resources and more effort into extending what we've done very successfully over the last 15 years in the area of plastics and composite to many other material systems.